Light is a form of energy that gives a sense of what? Of vision. Full stop. Or you can say, someone can say light is a form of energy that enables us to see. Light is a form of energy that gives a sensation of vision. Just like that, okay? After defining, then you go ahead and give relevant comment. Which relevant comment are you going to give your members? Now you give the properties. You give the what? The properties. You can say, now what, among other properties, remember we said light is electromagnetic waves. Light is electromagnetic what? Waves. And remember talking about electromagnetic waves. So all the properties of electromagnetic waves also the same as the one for light. One of them we said it travels through a vacuum. Do you remember that? Light travels through a what? Through a what? A vacuum. It travels and you can say at a speed of what? 3.0 exponent 8 meters per second. Are you seeing that? Then you can say it travels in a straight what? In a straight line. Are you together? So those are the relevant comments you must keep on giving. Okay? You keep on giving. So now after defining, you say light is a form of energy that gives a sense of vision, full stop. Then you give one of these two. You can say it is electromagnetic waves. It is electromagnetic waves and it travels at a speed of 3.0 exponent 8 meters per second. That is when the question is saying what is. But if the question is define light, you just say light is a form of energy that gives a sense of vision. Full stop. Don't add anything. Don't add anything if the question is defined. Am I clear, members? Members, am I clear?
Yeah.
Very good. We also look at different sources of light. Just to help those who have just joined in. We talk of sources of light. Sources of what? Light. Where do we get light from? We said there are many sources of light, members. There are many sources of light. Who can remind us sources of light? How many are there?
2.
Yes? There are how many?
2.
There are 2. The first one is it? The first one is what? Luminous?
Luminous light.
Luminous source of? And we said these ones, they produce their own what?
Light.
Produce their own light. And there are 2, this one again, they are subdivided into 2. We have natural, and what? Artificial. Natural we have, if you remember that, natural we have?
The sun.
We have the sun, we have the stars, we have
Glowworms.
we have the glowworms, what else? We have the fireflies. Okay. Members, we have the what? Fireflies. Yes, those are the common one. Okay. Now when we come to artificial, and they produce their own light, we have, what do we have? Artificial, what? We have the electric bulb, good. We have the electric bulb. We also have?
Candles.
We have lamps, not so? We have? What we have?
Candles.
We have candles. Good. We have candles. Burning candles. Burning. Should be burning what?
Candle.
Candles. Those are the things we look at. Then we also said we also have what we call the non-luminous sources of light. We said this one, they don't produce their own light, but they get light from other what? Other sources. This one, they get their light from where?
Other sources.
Other sources. An example we have the moon.
The moon.
We have the what? Mirrors. We have what? Mirrors. What else? We have reflecting surfaces. Any reflecting surfaces? Any reflecting what?
Surfaces.
Including mirrors. Now here we can also go ahead and we talk of planets. Planet is also a source of, like you see, like Earth. Earth reflects, right?
Yes.
Yes. So we can talk of planets there. Then also, which other one did we talk about? Apart from the moon, mirrors, reflecting surface, we have the TV. TV what?
Teacher, you said that the TV screen is under artificial light.
It's under artificial. Eh?
Yes.
Sorry. So this one this one they get light from other sources, but they're artificial. Good. Yeah, it's artificial. This one is off. This one is off from there. I think basically those are the things we discussed the other time, right?
It's a lot of the human body.
The human eye, yes, the human eye. The human
eye.
Not the human body, it's human eye. Okay?
Okay.
Then we also went ahead and look at different how light are transmitted, the transmission of light. We also look at transmission of what? Light. We said light, because it's an energy, which means light can neither be created nor destroyed, but only can be transformed from one form to another. So which means it can be transformed from one form to another, or can be moved from one point to another, because it's energy. Are you together? It can be transmitted or it can be propagated. And there are ways those light can be propagated from one point to another. And one of them we said we have what? We have what? We have the transparent. We have the transparent. We gave an example of those. I think you remember. Then also we have the translucent. We also have the what? The translucent. Then we also have the what?
Opaque.
The opaque. The opaque medium. Okay?
Yes.
Yes. Those are the things we discussed. Then we also look at how different bodies behave when they are subjected to light. Okay? How bodies behave when they are subjected to light. There are some which glows, and there are some which glows when they are hot, and some which glows when they are not hot. And we say the one that glows or that produce light or give of light when it's hot, we say they are called what? They are called fluorescent. They are called what?
Fluorescent.
Sorry, they are called fluorescence. Let me correct spelling. Fluorescence. We say this is emission. Is emission, or is a process by which light is given off by a material after it has absorbed it for some time. And we said there are some which give off light when they are hot. The one which give off which give off light when they are hot, we say they are what? They are called what? Incandescent bodies. Then the one which does not give off light when they are hot, they are called non-incandescent. So we have incandescents. We have the incandescents bodies. This one give off what? Light. When what? Give off light when? When what? When hot. Or when what? When heated. Now the one which give off light without, when it's not subjected or when it has not absorbed heat, we call them non-incandescent bodies. Non-incandescent what? Bodies. Yes. So that's what we discussed briefly the last time. I thought it was so that we discuss so that those who are not there the last time, they can be, we move together with them. But what I've prepared for you today, let's look at rays and what? Beams. Rays and what? Beams. Rays and what? And beams. Members.
Yes.
Do you have a torch there with you? Or have you ever seen a torch?
Yes.
When you flash in or when you switch on a torch, what do you see? Are you seeing a rays or you are seeing beams?
Light.
Members, when you switch on your torch or you flash on your torch, what do you see? Are you seeing rays or you are seeing beams of light?
Beams.
What do you see, members? You see what? You see beams. Good. You see what? Beams. But what make up those beams? What make up those beams of light? What makes it up?
Rays.
Is made up of what? Is made up of what?
Rays.
Rays. That's why when you, take for example, if you are, take for example, someone is driving at night. Let me just give a case example of that. You are driving at night. You see that as if there are some particles, not so.
Yeah.
You see some particles. You can see some maybe dust particles. You are able to see them, right?
Yes.
Yes. So now let's write down. Are you seeing that? Let me hope you are able to see my screen. We have said a ray is the direction of the path in which light is traveling. Write it down. A ray is the direction of the path. Is the direction of the path in which light is traveling. In which
Light
is traveling. Or someone can just say, or you can say, or a ray of light. A ray of light. I'm giving another definition, members, okay? Is the narrow path. Someone can put the word narrow path. Is the narrow path or direction taken by light energy. Taken by light what? Energy. A ray of light is the narrow path or direction taken by light what? By light energy. Full stop. Are we together, members? Are we together on that?
Yes.
Then we can say in another line, a ray of light is represented. A ray of light is represented by a straight line. Remember we said light travel in a straight line, not so? Is represented by a straight what? By a straight line. Is represented by a straight line with an arrow. With an arrow showing the direction. Showing the direction in which light is traveling. in which light is what? Traveling. Together, members. Are we together? Members, are we together?
Yes.
Yes. So we are saying it is represented by a straight line with an arrow on it. So the arrow is representing direction in which light is traveling. Light is what? Traveling. So can we draw? Can you pick your ruler, please? And everything we are going to be drawing here must be done with a ruler. If you don't have a ruler, with that one using a pencil as a ruler. There's someone using a pencil or a ruler as a ruler. Please get a ruler. I didn't say use a pick a pen. And then draw this line. Draw this line. Must be a straight one, members. Must be straight. Members, when I draw it like that, is that one a ray of light? When I draw it like that, is it a ray of light? What is missing? What is missing? What is missing? The arrow. Okay. So can you put the arrow there? Can you put the arrow there? And remember, we are saying is a narrow path. Is a what? Is a narrow path. Yes. So don't design. Don't draw it twice. Just draw the line once. Are you together, members? Draw the line once. Now that is a ray of light. Now let's go to beams. Let's go to beams. 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 We are saying when the first question I asked at the start, I said when you see a torch being flashed, what do you see? We said we see a what? A beam, not so. Now a beam is what we call a beam. Can you define? We are giving definition. A beam is a collection. A beam is a collection of light rays. A beam is a collection of light what? Rays. A beam is a collection of light rays. Full stop. Don't add anything there. A beam is a collection of light rays. Or alternatively, you can say a beam is a stream of light energy. A beam is a stream of light what? Energy. Full stop. Full stop. Full stop. In another line, there are three types or kinds of what? Of beams. Of beams. Full stop. These include what do we have? The first one is what? The first one is called what? There is what we call parallel. The first one is
beam.
Parallel beam. Then the second one is called the convergent what? Beam. Then the third one we have divergent what? Divergent beams. Those are the three types of beams. Let's start with the first one. Subheading parallel beams. Parallel beams. Parallel beams. Parallel beams. Let me take you where it is. Let me take you where it is. Is there? Are you seeing it there? But let's make it in a simple term. We are saying this is a collection. This is a collection of light rays. This is a collection of light rays that, just from the name, Just from the name. That do not what? That do not meet or what? Intersect. We said parallel lines. These are lines which do not meet or what? Intersect. And the distance between them are equal. Members, the distance between parallel beams or the distance between parallel lines are what? Are equal. That's why we're saying they cannot meet or they cannot what? Intersect. So can we draw them? Can we draw them? And make sure that the distance between them are equal. Make sure that the distance between the beams, between the light rays are equal. So just space it using the line in your book. Space it using the line in your book. Space it using the line in your book. Space it using a line in your book. Can you space it using? It's not a must that they must be on a 3D. You can draw more than that as long as you follow the principles. As long as you follow the principles. Are you together, members?
Yes, teacher.
Yes.
Yes.
That the distance between them must be what? Must be equal. The distance between them must be equal. Number two, convergent beam. Convergent beam. Just like the name, this one which means they are going to converge at a point, not so. They are going to converge at a common point. So we are going to say this is a collection. This is a collection of light rays. This is a collection of light rays originating from different directions, and converge or meet at a common what? A common point. The keyword that is there is what? A common what? A common point. And they are originating from different what? Different directions. And the distance between them keep on reducing as they converge or as they come to a common point. The distance between them. So the distance between them is not the same, but the distance between the light rays keep on reducing until they meet at a common what? Until they meet at a common point. So can we draw it? Can we draw it, members? So I have mine there. So that is my common point. Let me hope you are able to see what I'm doing. Let me hope you are able to see. That is what we have. They are originating from different directions, but the distance between the light rays keep on reducing until they meet at a common point. So which means all the light rays must be pointing at that common point. All of them must be pointing at that common point. You can even, it's not a must that they must be on a 3D members. You can draw as many as possible, as long as you keep the message clear that they are meeting at a common point. So this is our common what? Common point. Are you together, members?
Yes.
Very good, very good, very good, very good. Now let's look at the third one. Let's look at the third one. The third one we said is what? Divergent beam. We have divergent beam. We have divergent beam. We're saying this is a collection. This is a collection of light rays. This is a collection of light rays originating is the opposite. This one is the opposite of converging. So this time light are originating from a common point, originating from a common point and traveling in different directions and traveling in different directions and traveling in different what? Directions. That is what we call diverging. So diverging lights that are originating from a common point and traveling in different direction members. So in this case, we shall have if that is my common point, this is my common point, this is the common point. There we are. There we are. I can draw as many as possible. I can draw as many as possible. I can draw light rays as many as what? Possible. So this is the common point. Now light rays are leaving. So this means it must be out. This one is moving out. This one is out. This one is out. Like that. So this is the common point. The common point. Now another fact is here is that the distance between light rays keep on increasing as light travels away from that common point as they travel. So the distance between the light rays keep on increasing, which is not the case with the converging. For the converging, the distance keep on, remember, for converging, the distance keep on what?
Reducing.
Keep on reducing as light travels to the common point. But this one, they are traveling from a common point and are moving in different directions. So the distance between the light rays keep on increasing. Take note of that. Those kind of questions are very common in paper 1. Are you together, members?
Yes.
They are very common in paper 1. For parallel beams, the distance between the light rays are the same. The distance between the light rays are the same. For converging, the distance between the light rays keep on reducing as light travel to the common point. For diverging, the distance between the light rays keep on increasing as light travels away from the source or from the common point. Are you together, members?
Yes.
Now, what are the examples of the sources which produce this kind of light rays? I mean, this kind of beams. One of the examples that produce this kind of light rays is a torch. It's a what? Light from what? Light from where? A torch. When you flash on the torch, you see that light are diverging, not so? Members, is it true?
Yes.
Yes. One of the example, we have a torch. Then for converging, we have, here we have what we call the convex lens. We have the lens. These are the ones that converge beams of light. Then we have the concave mirrors. We have the concave what? Mirrors. Members, are we together?
Yes, teacher.
Yes. For convergence, we have convex lens, then concave mirrors. What about for parallel beams? What are the examples of the sources which give us parallel beams? Here we have plane. Here we have plane what? Plane what? Plane mirrors. Okay? Are together, members? Yeah, apart from a torch, because a torch, when you see that mirror there, that reflecting surface is made up of convex, what? Is made up of what, members? Convex mirrors. Is made up of convex what? Mirrors. You can see maybe from the car headlamps, the car headlamps, those are the ones that are made of convex mirrors, so they diverge light away. Okay? Okay? The cameras that you see, okay, for it, they diverge. That's why they're able to capture images from far distance, because they diverge light rays. From a common point, they see that they diverge. Remember, is there any question on light rays and beams? Is there any question there? Remember, is there any question there? Am I clear enough?
Yes, you're clear, teacher.
Very good, very good, very good. Now, the next thing we are going to look at is the subheading members, is what we call rectilinear propagation of light. Can you write the subheading? Rectilinear propagation, rectilinear propagation of what? Of light. Rectilinear propagation of light. Rectilinear propagation of light. We are saying, when, can you write this statement down? When light is produced, from where? From any sources that we have looked at. When light is produced from a source, it must be from a source. Light does not just exist anyhow. Okay? It's produced from a source and set outside. Comma, it travels along. A straight what? Members? When light is produced from a source and set outside, it travels along a straight what? Line. It travels along a straight what? Line. Now, when we come back from the break, we have less than a minute when we come back from the break. So don't wait. When you see that my screen has gone off, just remain there. So we shall look at definition. What is it? We shall define rectilinear propagation of light. When we talk about rectilinear propagation of light, what do we mean? We shall look at that one. Are you together, members? Members, are we together?
Yes.